So continuing on with our discussion of writing word equations and changing them to formulas. There are 7 what we call diatomic molecules that we're going to start to see in some of our discussions. So I kind of just want to give an introduction into this, and we're going to come back to these much later on. So they are what we call the 7 diatomic molecules. These are molecules that cannot exist by themselves. So what that means is you will never see hydrogen written on its own or oxygen written on its own. You can see it in a compound. So again, it's not like you can't see them together, but you do not ever see, if I'm burning something in oxygen, it's always going to be O2, or if it's hydrogen gas, it's going to be H2. And these diatomic molecules, okay, there are 7 of them. There's an easy way to memorize them. So on the periodic table, the number 7 is nitrogen. And if you look at the 7 diatomic molecules, they're nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So this looks like a natural 7. The only one that's weird is hydrogen. Hydrogen's over here on its own. So these are the 7 diatomic molecules, and you will always have access to them, but they are unique in the fact that they are different from other things that you find. So when you are drawing these diatomic molecules in terms of particle pictures, we do want to draw 2 circles touching. So this is oxygen, or this is hydrogen, okay? So when you're drawing them in the particle pictures, we're going to draw 2 circles touching as a diatomic. If it was just a piece of iron, then it's just going to be 1 circle by itself. So that's the distinction between diatomics and other things. The other thing you might see in the word equations are something called molecular compounds. And molecular compounds, we don't spend any time on them in first year chemistry, just because of we don't run into molecular compounds all that much. So they are interesting compounds because they use prefixes instead of charges, because they have no charges associated with it. And they are all the things, the nonmetals attached to other nonmetals. So they are all going to end in "ide," unfortunately. And they're going to use a set of prefixes. Okay, so mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Reason I'm pointing this out is there are a couple molecular compounds that we do run into in some of these word equations. And so I just want to kind of give you a heads up. So when you are doing these, you are not necessarily making them yet. We're going to talk about them in second semester. But you have seen CO2 before, and that is called carbon dioxide. So again, it ends in "ide." The di is suggesting I have 2 oxygens in the formula, because again, these are not attached ionically. That's something we'll talk about later. It has no charge. So that means the carbon is attaching to oxygen a different way. So we need a different system. So we're going to use a prefix to tell the reader. Now, the weird thing about this is, because I only have 1 carbon, there is no mono in front of the carbon. So that's only for the first element itself. So if you have, and I'll show you this example here. The way to remember this is, you know, another one, CO, okay? And this is the dangerous one. Carbon dioxide is dangerous for other reasons, but this is called carbon monoxide. Okay, so the mono is to suggest that I have 1 oxygen in that formula. Okay, and with oxygen, with the O, we are going to drop that second O when we use mono. So this is called carbon monoxide. So if I happen to have, again, that first element, if it doesn't have more than 1, I don't use mono, but I do use mono for the second element. So this would be called nitrogen monoxide. Okay, while the N2O would be called dinitrogen monoxide. So again, there's not going to be a huge focus on this in this first year of chemistry, but just know that that is the naming system you find with some of these non-metal attached to non-metal. And again, there's not going to be any quiz or test on this. It's just a good background information for you guys to keep track of these compounds.